Hello and welcome or welcome back to Cloud Native Wednesdays. My name is Erica and I am the program manager at MicrosoftReactors.com. Today, we are going to continue with the fourth episode of the Cloud Native track in the Championing Azure Collection series. This series provides an introductory overview of Microsoft Cloud Native and is perfect for those that are early in their developer career. Today, you will learn how you can leverage these technologies in a responsible way to enhance your applications. Before I carry on, I just want to say a quick word about Microsoft's Code of Conduct. We all come from different backgrounds, but we are all here to learn. So please be aware of each other and be welcoming and respectful. Thank you. And now let's bring you here as well, Chris. Hello.
Oh, hello.
Wait. Back to my slide. Hi, how are you?
Hello, I'm good, thank you.
Yes, thank you so much for being here with us again today. And for you guys, let me introduce Chris, who he is. Chris is a developer badass as a service that either creates or solves problems, as he says, depending who you ask. He loves creating and building things, whether it may be a new application, a new kitchen, or a new RC helicopter. You will see him building and doing stuff all over the place. In this session, we are going to look at containers and Docker, right?
That is correct.
Yes. And I think, first of all, you are going to look at how they work and what benefits they provide. And just removing some of the hype and the magic makes it easy to use them.
Yep.
Once you have covered that, you will have a look at how to create container images and start containers.
Yes.
Right?
That is correct.
Yeah. So I think the session is going to run for about. You don't have your image, by the way. Oh no, there you are.
Okay. I'm here.
There.
It becomes this weird thing since I'm running OBS Studio to be able to do some screen stuff.
Okay. Well, hi again.
Hello. I can do.
Sorry.
There you are. I can do that. Now you can see me. Hello.
Now we see you properly. Exactly.
Yeah.
Yeah. So today's session is going to run for about 40 to 45 minutes, and then we'll have some questions at the end. But you guys out there, please just ask your questions throughout the chat, and then Chris and I will keep a lookout on the chat and try to answer as we go. I think I'm going to put myself to the back now, and I will leave the word over to you, Chris.
Thank you.
Yeah, and I will see you in about 40 minutes. All right?
Absolutely.
Thank you so much.
Thank you. Yeah, so welcome everyone. Let's see if I can get all the screens lined up here. So the topic of today is Docker, and basically the title is Works on My Machine, Docker for Developers. So we're going to look at Docker from a developer point of view instead of from a DevOps point of view, where you often go, because most of the instructions I've seen so far focus on the running of Docker containers and the DevOps part of it. But I want to look at it from a developer point of view. So, as Erika said, my name is Chris Klug. I work at a company called Active Solution. I've been working with software development for 20 plus years now, and a lot of cloud native stuff, which means that containers is something that's sort of become part of what I do.
Sorry, Chris.
Yes.
Sorry to cut you off. The audio is very bad. That comes from you.
Is audio very bad?
Yes. And I see
weird.
the guys, as well. I see the chat is also saying.
The audio, is it low or just bad?
No, it's good. Now it's good.
It's good now?
Yeah.
Okay. I didn't change anything, so yeah, okay. Just let me know if there's any problem again. I will try and fix it.
All right. Thanks.
Okay. Yeah, so I work at a company called Active Solution, which is a company in Sweden where we do software development, a lot of stuff on the Azure platform, with people spread out across Sweden. So if you're looking for someone to work with, hello, we're here. But let's skip that and go into Docker. So most of us are deploying software. Yes.
It's bad again.
Is it bad? I'm not doing anything at all. And I've got massive connections to everything, so I wonder what's causing it.
But now
Because I've
it's
got
good
like
again.
a gigabit connection. Is it better again?
And now it's good again.
Okay, I would say it's something to do with the streaming stuff, because I'm not making any changes at all, and my connection should be pretty good here.
Yeah, I'm looking here, and then here I have the highest settings
Yeah,
here on StreamYard. So yeah,
that's weird. Is there anyone out there that's getting decent audio? I'm seeing lots of comments about the audio being bad, but is there anyone getting good audio? So I'm just trying to sort of see where the issue is.
now it's
No
good.
comments about that at all.
No.
Okay, so now it's good. No.
Okay, I'm going to try to remove my again. So I'm going to
Okay.
remove my stuff and see if
Yep.
it goes back to bed. I mean,
Okay.
let me see.
So
And
I'm getting now it's good from most people. Yes, good audio. Yeah, comedy guy pretends broken mic. Yeah, sorry about that. I am trying. My setup normally works well. So is it good enough for me to carry on? Anybody saying yes, no to carry on? Looking at the chat here. Okay, so I'm going to trust that it's good. So I'm going to just carry on then. So I'm assuming that most of us are working or will be working, depending on who you are, with deploying software in some form. And when we deploy software, we tend to deploy to different environments, right? So we might be working on our local dev environment. We might have one environment where we do our CD, CI deployments. We might have a UAT or user acceptance test platform where which is another environment, and then for production we might be deploying somewhere else, and for some of it we might be deploying on-prem, and some of it might be in the cloud and so on. And it's interesting being a developer and going as a consultant to different places, because I often hear the environments are pretty much identical. And yeah, pretty much identical is not the same thing. I just want to make that very clear. When it comes to development and deploying software, your environments should not be pretty much identical. Best case scenario is that they are actually identical. If they're pretty much identical, there are still things that can sort of happen. And this is where Docker comes in, because somebody at some point started looking at, are we the only people sending oddly shaped things to different destinations? And I know this is a corny sort of segue into Docker and containers, but no, we're not, because we have all of this postage or postal services that send things around the world. And what is interesting about this, even though it's a corny metaphor for Docker containers, is they have decided that they're shipping weird packaging, weird things all across the world, and they decided to use containers, which is where the name container comes from and where Docker comes from, basically. And the idea here is that they decided that let's have a specific standardized format for shipping things around the world. So for postal services, it means a physical container. They're only available in a certain set of lengths and heights. And all they really care about is the corners. As long as the corners are in the same place for the container, you can take that container and you can ship it around the world, and you can put it on a truck, you can put it on boats, you can use a forklift to build it, you pick it up, you can build houses out of it. But the only thing anyone across the entire world who works with containers cares about is that the corners are in the same place for every single container in the world. So that means that you get this universal thing that you can deploy, send across to wherever you want, and it just works. And that is where Docker comes in. And you can even see that the logo for Docker is a whale with containers on the back. And they're like physical containers. So they're based on the same idea as containers for postal services and shipping services and things like that. So what is Docker? I guess we need to start out with figuring out what is Docker and what does it do for us? And the idea with Docker is that it allows us to package our applications into a thing, a container, actually into an image. And I'll explain the difference between a container and an image in a few minutes. But it basically allows us to package up our application and all the things that we require for it to work into a standardized format that we can then ship around. We can use it on our laptop, we can use it in the cloud, we can use it on-prem, anywhere in the world where there is a compliant container runtime that understands this Docker image standard, which is a standardized format. They know how to plug that in. They know how to run that application. They know how to give it network access. They know how to give it CPU, RAM, and all of that stuff that it needs to run. So it's kind of like a VM in the way that we can ship VMs around, and as long as somebody has a virtual machine in runtime, they can run that VM for us, except for the fact that there's a couple of different VM formats out there. But it doesn't include the operating system, so it's actually, it runs on the host instead. And I also want to make it very clear that there is no such thing as a container, which is really weird. I'm doing a session about containers, and I'm saying that there's no such thing as a container. A container that you do build or create from a Docker image is actually an exe or an executable that executes on a server somewhere in its own namespace. So in your package, you define what executable do I want to run and what file system do I want to couple it with. And then when you deploy that to the host goes and says, I'll start that executable for you, and I will make sure that it only sees itself and the storage environment that you gave it. So let's compare, because I mentioned VMs and containers, and that they're different from containers. And VMs are quite common. They used to be very big. They're still very big, but for other things than application maintenance today, to be perfectly honest. So if we look at virtual machine, it all starts with physical infrastructure. And it doesn't matter if you're going to the cloud or if you're running on-prem or if you're running virtual machines on your laptop, there's a physical machine somewhere, hardware, something that you can plug into the wall, basically. On top of that, you install a host operating system. So given that you're listening to a Microsoft talk, a lot of you are probably running Windows. So you would install Windows on your machine. And then on top of the operating system, you install what's called a hypervisor. And what the hypervisor does, it basically takes all of your underlying physical infrastructure and creates a virtual version of that. So basically a software implementation of that your virtual machine runs on top of. So the virtual machine believes that it is running on physical hardware. It thinks that it has a CPU and it has RAM and it has a hard drive and all of that. But in reality, when it starts talking to all those resources are virtualized software resources that then basically forwards the requests to the physical infrastructure underneath. So every single machine believes that it gets its own set of hardware, but in reality, it's just a virtual set of hardware that forwards requests to the actual physical infrastructure. Then inside your virtual machine, you install another operating system. And then on top of that, you install any binaries and libraries and things you need on that machine to be able to run your app. So that could be installing IIS or installing something else that you need on the machine for your app to run. And then finally, you install your app inside of your virtual machine, and then you run this. And the cool thing here is then we can have many virtual machines on the same physical machine with physical separation between them. So one cannot automatically read things from the other and so on. So it's like having multiple physical machines, but they're on the same physical machine, which means that you can have higher density and use more of the resources from your physical machine. So the downside here is there's an operating system in every one of your virtual machines. And that has a couple of implications. It means, first of all, it means it takes up resources. So the operating system on the host machine uses a set of resources to run the operating system on the host. But then there's another operating system inside of each virtual machine that uses resources to run the operating system inside of the virtual machine. And the more of the resources from the physical hardware you give to the operating system, the less there is for your application to run. And on top of that, it also means that you have to patch the operating system. So for each one of the virtual machines, you have to go in and patch that OS, make sure that it has all the security updates and all of that stuff. And also, each virtual machine, every VHD file or every virtual machine image turns out to be several gigs large. So when you do Windows, it's been a while since I did VMs, but when I did VMs last time, I think you ended up with just a clean VM for a Windows installation, ended up being 10 plus gigs of data that needs to be transferred to be able to run it. Containers, on the other hand, are a little bit different. They still start out with infrastructure, same as with virtual machines, and they still start out with an operating system. But instead of a hypervisor, they have what they call the Docker engine. And the Docker engine is responsible for basically taking your Docker image, figuring out inside of your image what is the executable that you need to run, what environment variables do I need to set for that executable when it's running, and what kind of file system should I show it as being its own file system. And then it starts a container. And a container is literally just a running executable that runs in what's called its own namespace. So it doesn't see anything else. It doesn't see anything else installed on that machine. It lives in its own silo and its own little world. And when it looks for a file or disk, or rather if it looks at the file system, all it's going to see is the file system that the Docker engine set up for it and provided for it and said, this is what your file system looks like. So it lives in its own silo. But inside the container, we only have binaries and libraries in our app. So there's no extra operating system because it actually uses the host operating system, and the container is just an executable running on that host operating system, which means that there's no patching of the OS inside of each one of the virtual machines or inside each one of the containers. There's no resources being used for those extra operating systems running all over the place, and the container images become really, really small. You can even create, like the smallest image I've ever created was 4 megs, and on 4 megabytes, I could ship around a fully working web server that I could host in different places. And then you can run as many containers as you want on the same infrastructure. And the cool thing is, without the OS and without all of those extra resources being used for one operating system for each VM, it means that all of the resources for the infrastructure that you got goes into running your applications, not anything else. So you can get higher efficiency out of your machines. So what is the container then? I've been talking about containers and images. Well, you have these images that you build on top of. So first of all, you have the host OS that I was talking about. So that's the operating system for the machine that runs your containers. And then you tell it that, hey, I want to create a container, and I want to base it off, in this case, Ubuntu. So then the host OS knows how to download an image that contains Ubuntu. And that means that it has an executable for in Ubuntu to spin up and all of that. It will spin up like Bash or something like that inside of Ubuntu. You will get a file system, and then it will create a container. So basically your image, like the Ubuntu image, is read-only. That's just a package of, this is what an Ubuntu machine looks like. And then whenever you create an instance of it, you create a container that gets its own writable layer on top. So if you write anything to the file system inside of your container, it gets written to another layer on top of the base image. So the base image is never corrupted. It's never changed. It's a read-only thing, which means that you can run multiple containers on the same image, and you only have to download the image once. So even if you're running 650 Ubuntu containers on your same machine, they all just need to download one instance of the image, and then you add as many containers as you want on top of it, and they will never change the image because the image is read-only. But you can then say that, hey, not only do I want to have that base image Ubuntu, I have another image layer on top of that. So I have another layer where I go and add .NET Core. And then I have another layer on top of that that has all the prerequisites for my application. And then I run my container based on that. So that means that it will take, each one of these layers will basically be a layer of a hard drive on top. So it starts out with all the changes, all the things you need for an Ubuntu, and then on top of that, it adds everything you need for .NET Core, and then it adds everything else, and then it creates another last layer on top of it for the container B here. And inside container B, it is like I'm running Ubuntu with .NET Core installed and all the prereqs. And the cool thing is, with doing Linux containers is that you can actually change your Linux distro as well. So you can run some Ubuntu images, and then some Debian images. So on the same machine, I can go and add a Debian, and then I can add a layer which adds Emacs, and then I can create a container based on that. So containers is basically an instance of a running image. So the image is this read-only thing, and then the container is the instance. So if you're coming from a programming background, you can see the image as the class definition, and the container is the instance that you get when you new up an instance of that class. So images is kind of at the heart of everything, because you need an image to be able to run a container. And all images start out with a parent image. And that sounds really stupid. And yes, there is one image that doesn't start out with a parent image, and it's called Scratch. Scratch is literally empty. There's nothing in there. And if you're building native Linux code, for example, if you're building Go applications, you can package up your Go executable and add it to a Scratch image, and you will have a tiny little image with just your application inside of it. So I got a question here. So I guess the more containers, the physical resources required. Is there any way to improve performance, or is it just purely based on physical hardware? No, it's just physical hardware. It's as I said, every container is like running an executable. But you also have limitations. You can go in and say, I want to run this container here, but it's only allowed to use a quarter of a CPU, or it's only allowed to use 128 megs of memory. So you can limit what it's allowed to do, but it's still just, it runs on physical hardware. So you can add a gazillion containers to your hardware, but they are all going to share the same resources. So at a point, you're going to be adding more containers to your hardware than there's resources, and then they're going to slow down, or they might even die because they can't get enough resources for you to run it. Which is why you often add in these resource limitations, saying that this container is allowed to use half a CPU. This container is allowed to use a quarter of a CPU. And then Docker will actually say that, no, there's no more resources for you, so you can't start containers if you're trying to use more resources than you have. Does that make sense? I think so. I'll keep going. Write any questions you have in the comments. So you start out with your parent image, and then you create your own image on top of it, adding a reference to the parent, saying that I want to start out with this image, and then I'm going to add the things that I want inside of that image. And then in your image, you copy in whatever files you need. You can set some environment variables in that image. You can add some more files in there. And then finally, in your image, you say, when you start this image, I want you to run the x.exe is in this file, in this case, so an executable file. And then whenever you create a container, the container will basically, or what the container runtime will basically create a situation where you get the parent image with files A, B, and C added, and XYZ, and the environment variable XYZ being set as well. And then it's going to start x.exe, so it sees all of those files. And then inside of x.exe, if you were starting to look at the file system, you would be writing to your container layer. And the cool thing here is every one of these layers, so your image consists of multiple what's called layers, and each layer gets a hash. So if you go and create two images, but you do the same thing in both images, you don't get two separate layers. Because if you start out with the same parent image and you copy the same files, in this case A, B, and C, into the image, both of those layers are going to be identical. So what Docker does is it just basically says, hey, I've already seen a layer like that. I'm going to give you the existing one. So even if you download this image, there's only going to be one instance of that layer. So you can optimize the downloads and the sizes a bit by copying things in the right order. So you can, as I said, you can share basically layers between different images. So once you have your image, or you want to use somebody's image, say that you want to use, in this case, I have an image called zero-call my image. So to get that down on my machine so that I can run it, you go to the console and you write docker pull and then the name of the image that you want. So in this case, I want to go and what's called pull zero-call my image. So basically tell it, please download the image called /my-image to my local machine so that I can run that image as a container on my machine. So if we look at the command docker pull, so docker is the client CLI tool that we use, pull is the command that we want to do, and /my-image is the image that I want to download. This actually means this. So if you don't add docker.io as the domain name, the Docker CLI will default to talking to docker.io to find the image. If you are using another registry, another place to store your images than the default Docker one, you can store them in Azure, for example, in Azure Container Registry. In that case, you would go in and you would add your own registry and say, I store all of my images at something.azurecr.io. So then it would be docker pull something.azurecr.io/0call/my-image to get my image. And if we look at the address here, docker.io /0call-my-image, it actually turns into this address here where it adds a tag at the end. So the first part is what's the domain name of the image registry where the images are stored. What's the name of what's called the repository? Basically, what's the name of the image that I'm trying to download? And then finally, it has a tag. So every single image that you create has a tag. The last one that you created with this name, the last one you uploaded rather to the container registry, will have the tag latest. And if you don't define a specific tag, you will get the latest version of this image. But most people add a version number or some other tag to it as well. So I can say that I want to download /my-image v1.0, and that means that forever in the future I will get version 1.0. So if I go and upload a new version, which is 2.0, the users of my image can still download version 1 for the rest of whatever they need. So I'm going to ask here, can we take the image from one host to another host and it still works without any dependency? Ish. So you don't take it from one host to another, but you take it, you create it on one machine, and then you upload the image to a registry somewhere in the cloud, and then on that other machine you can download the image and you will just run that on the other machine as well. So and then you can basically share that image across as many machines as you want, as long as they have access to the registry where you have uploaded the image. So you don't go from host to host. You always need that middle step of a registry to keep your images. So we're going to see a bit of this working. I just want to do some more theory before we go into actually playing with it. So how do we get started? Docker is a Linux tool. Linux and Windows didn't mix previously. Now it mixes pretty well. So how do we get started? How much Linux do I need to know to get this to work? Actually, not a whole lot. Because you can go to docker.com and you go and you download Docker Desktop. So Docker Desktop for Windows, Mac, or Linux, you just download it, you run the installer, and then Docker is on your machine. If you're on Windows, Windows 10 or 11, it will use Windows Subsystem for Linux for running it. If your previous versions, you will have to get another version than Docker Desktop. It's called, not Docker Desktop, but Docker for Windows. And that uses virtual machines behind the scenes instead of using WSL. But I hope most of you are on Windows 10 and above. Once you've installed that on Windows, I'm going to assume Windows for this. These are the things you get. So first of all, if you go to your start menu, you can start Docker Desktop, which gives you a little systray icon that looks like a little whale with the containers on it. It's telling you that Docker Desktop is running. If you click on that, you get this Docker tool that tells you what containers are currently running on the machine, what images are available on your machine, if you want to start new containers. It also allows you to run Kubernetes using this Docker machine. So it just prepares everything for you. And if you go to your command line and you run Docker, the CLI tool, or Docker version, as I show you here in my PowerShell window, everything is pre-configured and done. You can just start running it. The Docker CLI is already set up to talk to Docker on your local machine, and you can just start working. So what does that look like? What does start working look like? Well, let's have a look. Let's see if I can find the right window here. Let's let's go to, that was not the window that I wanted. There are too many windows here. Let's go here. So this is my machine, and I have Docker. Let's see if I can make it a little bit bigger. I have Docker desktop installed on my machine. So what we can do here is we can do Docker. So that's the CLI tool.
Chris.
We do run to say I want to run a container.
Chris, sorry.
Yeah, did you say no worries?
Yeah, the sound is gone bad again.
The sound got bad again. Okay, so I guess the only thing I can do is kind of wait for the sound to get better. This is weird. It wasn't this bad last time, and it's the same thing. I've been using my setup for meetings all day, so I don't think it's in mine. I do believe that it is the streaming stuff, unfortunately.
I don't know. It worked perfectly for the past 15 minutes.
I know, and it's just weird. And
I see that you're not doing anything.
I'm trying my best. And as I said, I have a fat connection, so it shouldn't be my connection.
Yeah.
I have a pretty serious streaming rig set up, so it shouldn't be that. Is it still bad?
Yeah.
Okay, that's me. So the thing is, I'm not actually, the plug for the headphone was a suggestion here. I'm actually not using my headphone for this. I have a Rode microphone connected to a preamp connected to my machine. So I have like a streaming studio kind of at home. So it's not the plug for the headphone. Unfortunately, I'm pretty sure it's not my end. Everything is connected as it should, and the fact that I'm not touching anything and it comes and goes means that it's not this. Anyway to yeah. So the comment here from Daniel is it feels like it's a connection thing. Sometimes the sound plays fast, like fast forward, and sometimes it just disappears. I would say that's a streaming issue, unfortunately. Is it still bad?
Yes.
Kind of weird because I'm hearing you perfectly.
And we can't hear you perfectly.
Should I try and leave the studio and connect again and see if it gets better?
Let's try that. Yeah, leave and come back.
Okay, I'll be right back, guys. Just
I remove you.
A word from the sponsors.
Yeah, we'll have him back just in a minute. Sorry about that, guys. Please don't leave. He'll be back in a second. In the meantime, you can drop in the chat where you're tuning in from, maybe. And he's coming back.
Share my screen. I want to share that screen.
Now I can hear you well.
So you can all hear me now?
Yes, it's good. I'm adding your slides as well.
Okay.
Yes.
Then I'll just keep going. And feel free to jump in if it goes bad again. I'm doing my best.
Yes,
okay.
It looks good.
Cool. So what we got here is I'm going to jump in. Docker run, basically say I want to run a container. And then I'm going to add -it, which is basically I want to run interactively. So once you connect to a container, I want to run the container, but I also want to connect to it so that console in and console out is connected to my terminal so that I can play inside of the container. You can also run it in the background and things like that. So let's do that. And then we do Ubuntu to run an Ubuntu container. And that takes about that long. Now I'm inside of an Ubuntu container. So starting up a container is ridiculously fast. So in this case, it took 2 seconds or 3 seconds maybe to start up Ubuntu, and I'm actually inside of Ubuntu now. So I can look at inside Ubuntu, and we can see here that there's just 2 commands running inside of it. There's the bash command, which is what I'm working with, and then there's the top command that just ran now. So I'm inside Ubuntu now. It's clear here, like that. So I'm inside Ubuntu, and if I go exit, so whenever the root executable inside of the container stops running. So I started up bash and I connected to bash. And as soon as the bash executable stops running inside of the container stops. So if I go and look at Docker, let's see, are there any containers running on my machine? It says, no, there are no containers running on my machine. But if we do docker ps, which is lists all the containers, and do -a, and basically saying, show me all containers on my machine, even if they're not currently running, you will see here that I have, can we still see that? So we'll do that just quickly so you can see. Yeah, I want to do that. So it's just a one-liner. So you can see here that I have 3 containers on my machine. I have the Ubuntu one that I just ran. It was named Naughty Kirch. So basically, it makes up names for all containers. And then I have 2 SQL Server containers on my machine as well that I'm using for my dev work on my machine. And as you can see, they're all stopped, but the one that I just had stopped 33 seconds ago because I exited Bash. And as I said, as soon as I stop the last the executable that's running inside of the container dies because it is just a running executable. Then we can say docker rm and to remove a container. And what I can do here is I can do docker rm and I can tell it to remove Naughty Kirch. Or I can go and say docker rm and use the container ID. But we don't need the whole container ID. All I need is enough letters and numbers to be unique. So in this case, I can do one rm1fb, and I run that. And now, if I go and look at my container list again, you'll see that that container is gone. It's like it's never been on my machine before. So that's kind of cool. And then we can do docker run. Actually, let's clear the screen first and do docker run. And then we'll do another interactive session, so attached to it, so that I can play inside of the container. I'm going to go --rm. So --rm is another parameter that allows you to remove the container as soon as it stops. So it never stays in a stop state. So whenever I kill the container or whenever I stop the container, it goes away and disappears. Which is really cool when you're just playing around and trying it out. You don't want to have all these old containers laying around so that you can restart them, but you just want them to go away because I'm just playing around right now. And then I can say Alpine, which is another Linux distro, which is really, really small. The Alpine image is something like 4 megs. And if I run that, I'm now inside of Alpine. You can see that I got a file system. It shows it a little bit different than Ubuntu because the settings are different. And we can see in here, instead of running bash, this image actually runs sh, so the shell, and it still has top as well. So I am inside this, and whenever I go exit, like that, it stops my container. And if I do docker ps-a, you can see here that the image is gone, the container is gone. It just disappears, and it's like it's never been there before. And once you've deleted the container is gone. Everything you've done inside of it is gone. So this is really cool. Well, really cool. I wouldn't say really cool, but it's cool-ish. But let's try something else, because what we don't want to do is we don't want to go and start up Ubuntu and sit around and play around in the Ubuntu bash. What we want to do is we want to build images that we can use. So what I'm going to do is I'm going to show you 2 ways to build an image. I want to show you the bad way and the good way. We're going to start out with the bad way, and let's do docker run. So I'm going to run a new container. It's going to be interactive so that I'm inside of it doing stuff. I'm going to give it a name. So I'm going to call it interactive build, like that. And then what image am I going to use? Well, I'm going to use an image that comes out of mcr.microsoft.com, which is Microsoft's container registry instead of the Docker one. And from there, I want to get the image that's in the .NET registry, or .NET part of the registry. And I want to use .NET Core. And I want to get the SDK. I'm going to do 2.2 here, where you can do newer ones. But so I'm going to use the image which uses the .NET Core SDK 2.2 installed. So I'm now inside of the image, and if we look inside, I've got everything in here. And if we run .NET, you'll see that .NET is already installed in this image. So this is really cool, and I already had it on my machine. If the container wasn't on my machine when I ran the docker run command, it would first download the image to my machine and then start the container. So now I'm inside my container. So inside here, I really don't learn that. So I'm going to clear it out so you can see here. What I'm going to do is I'm going to say mkdir app to create a folder called app. So I'm going to go ahead and I'm going to jump into to that folder. Then we're going to do .NET new MVC to create a new MVC project. So this is using the .NET SDK to create an ASP.NET project, and I need to do one little thing in here. I just need to remove one little folder in here called properties because it contains some files that I don't want for this to work properly. So now, if we do ls in here, you can see that's a standardized ASP.NET Core MVC project. So what I'm going to do now is I'm going to jump out of this application. Like that. If I do docker ps-a, we can now see that I have a stopped container called the interactive build. Once I have that, I can now go ahead and I can say docker commit. Basically, I want to commit what is in this container into an image that I can reuse. I need to give it some extra commands or configuration. So I'm going to say that the working directory for this container is going to be /app, which is where I've located my app. And then I want to tell it that the entry point, so basically the application, the thing to run when I start my container should be .NET run. And then I tell it that I want to use the interactive build container. And I want to call it interactive. So that's the name of my image. If I run that now, it gives me this thing here. So what it's done now, it's taken that the state of my container that I just created with my Docker with the .NET application inside of it and turned it into an image. If we do docker ps-a, we can see that the container is still here. So I'm going to say docker rm dff. Like that. So zoom a little bit. I will zoom in a little bit. Here it is. So I removed that now, and if we look at it, my container is now gone. But if I go and look at the images on my machine, which we can do with Docker images, we can now see that there is an image in here. If I go to, there's lots of images in here. I've been working on stuff. There is an image in here called interactive that was created 5 seconds ago. So with that image, I can now go ahead and I can say docker run --rm to remove it when I'm done with it. I want to be able to talk to it, so I want to be able to talk to it to a port. So I'm going to be able to browse to it. So what we do is we do -p to say, can you please forward port 8080 on my local machine to port 80 inside of that container. And then I want to use the image called interactive, like that. Run that now, you're going to see that it's going to start up a container. I'm not interactively attached to it, but I'm still going to see all the output from the container. So I can see here that the application started. It says that the hosting environment is production. It's located in app. It's listening for port 80. And since I said that I wanted to port forward port 8080 on my host to port 80 inside of my container, I can now go ahead and say, pull in a browser and go localhost port 8080. And there is my application. And if we go back to this thing here, it's going to say here that there's some HTTPS redirect middleware warning thingy that's in here. But what I've got is me browsing to the application that was inside my Docker container. And if I go ahead and I stop this thing, Control-C to stop it, give it a little while for it to actually stop, because it has a grace period where it allows .NET Core to stop, I hope. Hello. So why is that not stopping as it should? Okay, so it locked up my window. Let's go ahead and I don't want Linux. I want to have that thing. Let's go cd:/docker demos. I'm back in action again. We'll do docker ps like that to see if it's still running. It is. So what I'm going to do is I'm going to say docker stop 4d4 to stop my container. It should stop now, I hope. Come on. There it is. Now it stopped, and this thing now stopped as well. So now I stopped my container, and just to verify that I'm not cheating, if I go out back here and refresh, it's not going to answer because my container is now gone. So that's kind of cool. That's one way for us to build up our images so that we can run the applications, and we package our applications up like this. The problem with this solution that I just showed you is that if I package up my applications like this, it means that whenever we create a new version, somebody would have to go and start Docker, create an image, copy across files, do a bunch of configuration. We don't want to do that. We want to make this so that you can replicate it and create images in your build system, for example. So what I'm going to do is I have a couple of applications here. For example, this demo app here. The demo app, what it does is really doesn't matter. It's just an MVC application. There's nothing important in here whatsoever. What we want to do is we want to go ahead and create what's called a Docker file to be able to create an image for this application that we can reuse. So if I go and add a new file, and I'm going to call it Docker file, and it's not something that I just made up. It should be called Docker file. As you can see, as soon as I name it Docker file like this, it gets a little icon, and everything is fine. So the question is, can I commit my image to GitHub? No. So what you do is instead you create your image and you don't upload it to GitHub. You upload the image to a container registry of some sort. What you can commit to Docker to GitHub is you can commit the Docker file that is there for somebody to create an image for you. So if you don't want to pay for hosting your image so that other people can use it, you can still give them this Docker file and they can just run the Docker file to create an image locally on your machine or on their machine. So we see here the Docker file. What I'm going to say is I'm going to do the same thing I just did interactively. So I'm going to say from, and then I have to tell it what base image do I want to use. Well, mcr.microsoft.com, if I spelled that correctly. So I want to do that /.net/core/SDK:2.2. So that's the image that I want to start from. And I want to go ahead and I want to run a copy command. So can you please, in this case, copy everything local from this local directory, so basically the same directory that the Docker file is in, so all of this, into /app inside of my image. And then we want to set the working directory. So basically, hey, when this container starts up, the working directory should be /app. And then we want to run a command. So basically, during the creation of our image, we want to run .NET restore to restore and get all of the NuGet packages that we need to run the application. So that means that all the NuGet packages will be downloaded and added to the image during the image creation and not when you actually run the image, run the container. And finally, we want to say entry point. And we use this weird syntax where you basically do an array of strings saying that, hey, I want to do .NET run inside of that folder. So this is being run while the image is created, and this is being run when the container starts up. I also want to do a little thing. I want to add another file in here called docker ignore to tell it that, hey, I don't want you to include the bin folder and the obj folder because those are unnecessary to have in my image. So with that in place, I now have a reproducible build system or a image creation. So we go in here and we go to, what was the demo app? cd demo app. That was the wrong place. Let's go ahead and try that again. cd demo app. There we have it. So look in here, we can see that I have the Docker file. So what we can do in here now is we can say Docker, once again, same CLI, and then we do build. So that's the command. So please build. You will find the Docker file in the local folder, so basically dot. And I also want to add a tag to it. So basically the tag you add is the name of it. So I want to name this image demo app. I run this now. What you're going to see is that it actually runs through. You can see it does a bunch of things. It transfers the Docker file. It loads the Docker ignore file to figure out what to do. It gets the base image. It transfers. It copies my files across. It changes the work directory. It runs .NET restore. It exports it to an image. And if I do Docker images, and I scroll to the top, you can now see that there's an image here called demo app. And if we run Docker run, let's do --rm so it gets removed. We're going to do -d, which is basically detached. Run it in the background. I don't care what you're outputting. I just want you to run in the background. We map port 8080 to port 80 inside of my container. and I want to use the image called demo app. Run like that. It starts the container. If I do docker ps, you will see that there is a running container in here. You can see here that it uses the image demo app. It uses the command.net run. It started 3 seconds ago. Sorry, it was created 3 seconds ago. It started running 7 seconds ago. It maps some ports. And if I go back to my browser and I refresh this now, because it was the same port 8080, it's going to start up my extremely ugly application. But what it shows me is that it's running off a machine that has that name. It's in that directory. The operating system is Unix, and the environment is production. And if I go docker stop, let's do epic churn. Like that, it's going to stop the image, and if I try to list them again, it's actually going to be gone, even if I do -a, because I did the --rm. And if I go back to my browser and I refresh it again, it's not going to respond because there's nothing there. So I know that I'm going to go a little bit long. I'm sorry about that. The audio stuff caused a bit of problem, so hopefully bear with me. There's not a ton left. But I want to cover a few more things that might make sense. So storage. The problem here is that you've got a few different options for storing files, because most of our applications do need somewhere to store things more or less permanently. You can store things in your container. You can add what is called bind mounts. You can add what is called volumes, and you can add what's called temp fs mounts. So container storage is basically you just write to disk as there's nothing, and you just write it to the storage. The problem with that, it works fine, but remember, whenever your container goes away, anything you stored inside of the container goes away as well. So as long as the container is around, this data is there. As soon as the container goes away, the data goes away. Bind mounts are basically where you take a folder or a directory on your local machine, and you add it as a directory inside of your container. So if you write something in your container, it writes it to the host. And if you add something to the directory on your host, it's available inside of the container as well. So basically, they're sharing data. So it means that the files are on the host and not the container. So if you kill the container, the files are still there, but it's still bound to one host as such. So it's still on the host. Volumes allow you to basically create a storage area inside of Docker that Docker takes care of, and then you can share that storage between different containers and such. And the lifetime of the data is managed by Docker. It's not limited to the lifetime of the container. It's limited to the lifetime of what they call a volume. So basically, a storage area that Docker manages. And finally, you can do something called temp fs mounts, which is basically you create a temporary file system mount. It creates a very specific file system for your container that is only in memory. It never writes anything to disk. So if you have secrets, you can put those secrets into the temp fs mounts, and they're never written to disk. So even if somebody gets access to your machine, there's no way to actually read those things. And whenever you delete your container, it's never been persisted at any time. So you can never go and sort of take the hard drive and try to reverse engineer and get your secrets, which is why it's a good place to store your credentials. So I have one more demo here, and I'm going to make it really quick. I just want to show you something. I'll make it quicker than I normally do. But I have this image viewer web here, which is it's a pretty stupid little application. All it does, it has an endpoint where you can show images. And if we look at the controller, what the controller actually does, that was hard to read, but it basically goes and finds all the JPEG files in an address or in a path called images. So basically under www root images, it gets those images and they show it on the website. And then you can upload the images and they get stored into that address as well. So I have a Docker file for that. It does the same thing as the previous one. It creates a .NET Core SDK image. It copies across the app. It runs .NET Restore, .NET Run. So it's identical to what I had before. I go out here and we do cd -- cd image viewer web, and then we run Docker build, and we call it image. Let's call it image viewer, like that. We run that, so it creates an image like that. Okay, so now I have that running. But the problem here is that inside my application, all it really does, it reads and writes that www root folder. So if I start an image, an application or a container based on this, and I upload a file, it gets written to the container, and then whenever the container goes away, the storage goes away, which is pretty bad for an image application. You really want to store the files more permanently. So what we can do, I'm going to see here if I have some, let's see here, do I have some pictures in my pictures folder? That was not the one that I wanted. Pictures, that's the one. Yes, there's a picture in here, so that's good. So what we're going to do, I'm going to try something here. We're going to say docker run to run a new container. We're going to map port 8080, nope, -p, map port 8080 to port 80 inside my container. I'm going to run it in detached mode, so basically in the background, so I don't want any output. I'm going to remove it when I'm done with it. And then what we've done before is I've given it a name, so I'm going to name it IV for image viewer. I'm going to use the image called image viewer. So this would run the container for me as such, but I'm going to go in here and I'm going to add something called a V, so a volume. And then I'm going to say, can you please, and I'm going to use PowerShell for this. So I'm going to get the user profile, so basically the address to my user profile folder, and then say pictures. And I want to take that folder on my host, on my local machine, and I want to map that to /app/www root/images inside of my container. But Chris, inside of your container, you already had a folder called www root/images in which there were images. Yes, there was. But the thing is, once I do this, I actually overwrite, or I replace what was in my image with this volume instead. So if I run this, you will now see that if I go back to my browser and I refresh this, you will see this amazing website where you can see all the images from my my images folder. And if I were to upload an image, let's upload something. I don't have anything there. Do I have an image somewhere? Yes, I do. I have an image of myself somewhere. Let's try. I have no idea what that is. Let's submit that. That gets uploaded. And if I now pull out my Explorer and I go to my pictures folder, you will see that it has just uploaded the image to my pictures folder here with a grid name like that. And if I remove that and I refresh this page here, you will see that it disappears. So I'm not sharing data between, which is nice when you're doing development inside of Docker. You can actually share source code from your local host into a container, and then inside the container you can add like .NET Watch to see whenever there's changes and things like that. Now we can do docker stop IV to stop my container and remove it again. So that's about it. I also want to mention networking. Well, networking is complicated. You have the network. What I want to just show you here quickly is that your host is going to have one IP address, and then there's some WSL magic going on in here, and then you get a network, which is the Docker network, which is generally 172.17.0.1. And then inside of that, your containers will get IP addresses from that 172.17 address range, and that's cool. But you can never talk to them on 172 because you don't have access to it. And also, if you want to talk between two containers, you don't want to do it based on the IP address because IP addresses change. So whenever you create a new instance of container 1 or container 2, the IP addresses will actually be dynamically generated for that instance. And basically the last thing I want to mention as well is Docker Compose. If you want to run multiple containers and you want to have them talk to each other, you can use this thing called Docker Compose. So it's a YAML file you create, and it looks like this. And you basically say, I have these services that I want to run, Nginx and web. And then you say, hey, the Nginx you can find inside of this folder here, and I want to map these ports, and I want to attach it to a virtual network called my network. And then I want to run another image called my image, and I want to set an environment variable, and I also want to connect that to my network. And then I create a network down here. And then if you run Docker Compose and you give it this YAML file, it will actually spin up 2 containers, one for Nginx and one for web. They will be connected to the same network, and the Nginx container can actually reach the web container based on the DNS record web, and the web container can reach the Nginx container based on the DNS record Nginx. So this allows you to create a microservices environment where services can communicate with each other, and it's all defined in this one YAML file. And if you want to run it, you just do Docker Compose up and you give it the YAML file. And when you run that, it will create 2 containers, and they can communicate with each other. And when you do Docker Compose down and you give it that YAML file, it basically removes your containers for you. So it allows you to run multiple services. And that's kind of cute, but Docker is only running on one machine here. So it's only on my local host. So if you want to run Docker on multiple machines, you want to have a cluster and load balance and everything, you actually have to look at some other services on top of Docker or on the side of Docker. And you can use something called Docker Swarm, which is built into Docker. I wouldn't recommend it because not too many people are using it, and it's quite rudimentary. You can use Mesos or DCOS, which is another way to run containers in a cluster version. Not a lot of people are running that anymore. It seems like Kubernetes is the thing that wins, the orchestration system that wins. So if you want to run a clustered environment with multiple containers and things like that, Kubernetes is kind of the way for you to run that in a nice way. And I also want to say, I've shown you Linux stuff. You can run Windows containers as well. So you can do containerized applications on Windows as well. The only difference is that you cannot change Windows version or anything like that. It runs on your Windows host. And you use PowerShell and things like that to get things installed inside of your container. So you got IIS installed and things like that. And your images become quite a bit larger than they do on the Linux side. But it's definitely possible for you to containerize your Windows applications as well. I had a question here. Is it better to have a Docker file per environment in a multi-environment setup, or is it better to have the same file? Yeah, so no, you really don't want to have a Docker file per environment. So what you want to do is you want to make sure that you have one Docker file to create an image, and then inside of your application that's inside of the Docker container, you find all of your configuration using environment variables. So when you start up a new container, you can set environment variables inside of that container. And as long as your code then goes and looks at different environment variables to figure out its configuration, it means that you can use the same image for all of your environments, because you really don't want to add like credentials and database connections and stuff to your images, because all of that can be read. So what you do is you create what you normally do when dev and test, you build an image instead of building the software package. And then when you deploy that, you normally deploy it and you update the configuration files when you do a regular deployment, or you set the environment variables where you deploy it. For Docker containers, it's the same thing. You take the image has no configuration inside of it. You set environment variables that has the configuration, and then you have your app look at environment variables for the configuration for things like connection strings and other settings like that. So I want to thank you all for listening. If you have any questions, I'll be around for a little bit more. Otherwise, if you have anything else, you can always ping me on Twitter. I'm available at ZeroCall if there's anything like that. And if you're from Sweden and you want some free stickers, you can go to activesolution.se/stickers or use that QR code there, and we can send you a little sticker pack so you can have a look at have some cool stickers to put on your laptop. And don't forget that there are more sessions available in this series. So there's an AI machine learning series that a couple of friends of mine are handling. Alan Smith and Robert Folkesson has still got custom vision and machine learning stuff. And for the cloud native track, I talked about containers and Docker today. And Jacob will be talking about Azure Container Apps. So basically how to run your Docker containers in Azure. And he will also talk about Azure Kubernetes Service. So how you can run your containers in a clustered environment to get load balancing and all of that for a production environment. So the question is, I have another question here. Are there other alternatives to Kubernetes in Azure App Service? So in Azure, you can select Kubernetes as AKS, so Azure Kubernetes Service, if you want to have a Kubernetes cluster. you can host your containers using Azure App Service for containers. So basically, you create a web app. You can host that web app as a container in Azure as well. You have Azure Container Instances, where it's basically more sort of a batch job kind of thing. Spin it up, do some work, and then spin it down again. It's not really meant for long-running things. And finally, you have this new thing called Azure Container Apps, which is a way for you to basically get kind of a Kubernetes situation, but Microsoft manages all of the Kubernetes stuff. You don't have to care. You just tell it using the Azure CLI that I want to run this container in this many instances, and I want to have load balancing and all the things you can do in Kubernetes without actually having to run the Kubernetes cluster as well. So there are quite a few different options for you for running Docker containers in Azure. Let's see, I've got so many questions, but I will keep them for another time. Thanks a lot for it. Thank you, Daniel. Thank you, everyone, for listening. As I said, if there are any questions, feel free to ping me on Twitter. I'm more than happy to answer questions. And I think, so Erica also shared that fearofoblivion.com, which is my blog. There's an intro to Docker. It's a 5-part intro where you get everything that I talked about today in much more depth and more. So if you like with the way that I explain it, there's a written version of this talk in extended version that you can have a look at as well.
Thank you, Chris,
Thank you.
for another fantastic session. Yeah, we did have a bit of technological issues.
Yeah, sorry about that.
It's okay. So guys, ask your questions if you have any, and I love it how you Chris and your colleagues always do my job, and we
try our best. We pride ourselves of knowing as much as possible and being sort of up to date with technology, and we really love sharing it with people, and that's kind of a big part of my job, is actually going to conferences and talking and doing stuff like this to share knowledge and get other people interested in new technology. So I'm just happy to help out.
Yeah, that's fantastic. And then it's actually quite very well leads to my next point that I wanted to mention is to our audience that on the 22nd, on the 22nd of February, so in like 2 weeks, I actually have an interview with Chris, Alan, and Peter, whom if you've been following this series, you have met. Where I'm just going to have like a chat show with them about their passion for technology, their education, and everything that they do for the community. So make sure that you join that session. I'm just going to drop actually quickly a link here where you can sign up. We just published it. You can
if
sign
you follow
up
me on Twitter, it's in my Twitter feed because I just tweeted it today to say that I was honored to be part of that interview. It's going to be a lot of fun, I think.
Yes, it is definitely going to be a lot of fun. I'm so looking forward to it. No slides, no nothing. Just sharing the passion, and I'm so looking forward to it. So make sure you guys tune in for that in 2 weeks' time. And I don't think we have any questions now, do we?
No, it seems like I've answered all of them. And as I said, if there are any more, Twitter is the way to reach me.
Yes, definitely. And I've dropped a few links in the chat, so make sure you also, you can just carry on and learn some more and follow Chris as well and his journey. I think we're done for today. I will say another big thank you.
Thank you for having me.
Yes, thank you. And now, you guys, thank you so much for viewing from wherever you are. Thank you and bye.